Welcome back. Today we're going to look at the first part of section 6.1. Our topic is roots and radical expressions. And our learning target today is to find the nth roots. So corresponding to every power there is a root. For example, just as there are squares or second powers, we have square roots. Just as there are cubes or third powers, we have cube roots, and so on. 5 to the second, or 5 squared, is 25. That means that if we square root both sides, we're saying the square root of 25 is just a 5. If 5 cubed is 125, then 5 is considered the cube root of 125. If 5 to the fourth is 625, then 5 is your fourth root of 625, etc. So that defines our nth root for us. Couple vocab terms that we need to know. The little number inside the root is called the index. So if it's a square root, it's implying a 2. We don't typically write that 2 in there. It's just assumed if you see that, it's a square root. But any other index has to be notified. So we have to put in a 3 if we want to cube root it. We have to put a 4 in for the index if we're trying to fourth root it. Okay, so the only one that we don't have to put in is the square. Our definition says if a to the nth power equals b, and they're both real numbers, and n is a positive integer, then a is considered the nth root of b. Okay, so if a to the nth power is b, then a is the nth root of b. We have two situations that we have to think about. When n is odd versus when n is even. If n is odd, we get one answer. And it gets the sign of the number that we're square rooting, cube rooting, whatever. Okay? So if n is odd, like we're taking the cube root of a number, let's say it's a negative 64, okay? When we cube root that, we're going to get a negative answer out. And we'll talk more about where I'm getting that 4 from in a minute. But the sign of our answer is just going to match the sign of what we're trying to take the root of. When our power or our index is odd. If our index is even, we're going to get 2 answers out because of that plus minus. So for example, if I am taking the square root of 16, I have to consider that I could have it be both a positive or a negative 4. So just like when we're solving quadratics, okay, we have to remember that plus minus. However, if b is negative, so we're trying to take an even root of a negative number, then we are going to get no real solutions. That's when we get those imaginary answers. And for our topics today, we're looking for real solutions. When the directions to find the root are in words, we have to treat it like we're solving an equation. All right, that means for even roots, we have to remember our plus minus. Okay, so if it's written in words, in other words, it just says find the square root, then we have to assume they want both answers. So for our first one here, find all of the real square roots of each number. There's no square root symbol on there. They're just saying it in words. We have to assume they want both. So we would write plus minus the square root of 169, and the square root of 169 is 13. So we would give an answer of positive and negative 13. For 196, we are taking the square root, so we have to consider both of these because it's an even root. The square root of 196 is 14, so we're going to get plus minus 14. For the square root of negative 121, remember if we're trying to take an even root of a negative, we're going to get no real solutions. Okay? We'd get imaginary ones. They're not asking for that today. The next one says to find all the cube roots, all of the real cube roots. Now we're talking about odd roots. Okay? A cube is number 3. 3 is an odd number. So we want the cube root of 64. We want the cube root of 125. We want the cube root of negative 216. So here we're just going to get one answer for each of these. And hopefully you know your perfect squares, but You may not be as familiar with your perfect cubes and your perfect fourths. So we have this power chart here. The top number tells you what kind of power you're taking. All right, so if I took all of these numbers and raised them to these powers, I'd fill in my chart, okay? I'd fill in my rows. For example, 3 to the second power is a 9, okay? So 3 here, second power here, I'm getting a 9 for an answer. Well, we can work backwards to find the roots. So for example, if I'm trying to find the cube root of these numbers, then I need to look at my third power and work backwards, okay? So I'm looking at this third power column. I find in my column a 64, and I look backwards to figure out that my root had to be this 4, okay? If I'm trying to take the cube root of 125, I find 125 in my cube column. I look far to the left and see its root is 5. For 216, I find that in my column. I look back and I see its root is 6. Now, for the negative ones, let me just fill in our answers here. We said the cube root of 64 was 4. The cube root of 125 was 5. The cube root of positive 216 is 6. So the cube root of negative 216 would just be negative 6. Okay? Our last section here, it says to find all the real fourth roots. So now we're looking at our fourth powers. Okay, we're going to use this column of numbers. So we're going to find 256. It's right here. We look far to the left and we see that we have a 4 for a root. Now, because we are doing an even root, right, the number 4 is an even number, we have to include both the plus and the minus. So we took the fourth root of that, we get positive and negative 4 for an answer. If you're taking the fourth root of a fraction, like 16 divided by 81, we still have to include that plus minus. And we just take the fourth root of both the numerator and the denominator. So going back to my fourth powers, I see 16 here, its root is 2. I see 81 here, and its root was 3. So that will simplify down to plus minus 2/3. To take the fourth root of a negative number, remember an even root of a negative number, we're going to get no real solutions. All right, so if the question is already written out with your square root or cube root or fourth root symbol, whatever, already written down, then you do not have to use the plus minus. They are looking simply for the what we call the principal root or the positive root. So for this one, it says, what is the square root of 169? The square root symbol is already in there, so we are simply looking for the positive root. Square root means we're looking at our second power here and working backwards. So we have 169, work backwards, we just get a positive 13. The cube root of negative 512. So now we move to our cubes. We find 512. We look back at its root and it's an 8. We are taking an odd root of a negative number. We are just going to get the negative root out. So a negative 8 instead of just a plain 8. The fourth root. Go to our fourth power column. We find 16 and we find 625. Their roots are 2 and 5. So we end up with a 2/5 for an answer. We're simply taking the fourth root of the 16 and a fourth root of 625. So all of the ones that we've done so far have just been numbers. We're taking roots of numbers. But there will be some where you have variables inside. So our definition here, for any real number a, if you take the nth root of a base or a variable to an nth power, we have to be careful whether n is even or odd. if n is odd, we're just going to get a out. Okay? So we just get a, no plus minus, nothing to worry about, if n is odd. However, if n is even, then we are taking some base to an even power. So regardless of what the base was, when we take it to an even power, it becomes a positive number. Then when we take its even root, we're going to get a positive number out. Okay? And to ensure that it comes out as a positive number, we put absolute value bars around it. All right, so when you are simplifying radical expressions with a variable, we take the nth root of the number, which is what we've just been doing, and then we look how many times can n go into the exponent of the variable. And that's going to become the outside exponent. So if it is an even root, we use what's called an even-odd rule to assess if the variable needs the absolute value bars around it. All right, let's go through a few examples and I'll explain what we mean by that. Our first one here, we have a 16 and an x to the 8th. We are trying to square root it. We separate it. We take the square root of 16 and we take the square root of x to the 8th. Okay? Well, we know the square root of 16 is 4. When we go to do the square root of the variable, notice we are taking an even root because it's a square root. 2 is an even number. And we're taking the even root of an even power. So if the power is even and the root is even, and if the power ends up coming out odd for an answer, then we need our absolute value bars. But in this case, we're saying we're taking the square root of x to the 8th. So we're looking at this and saying, how many times can I take 2 into that 8? And it would be 4 times. So we're going to get an x to the 4th out. Since it started out even, an even root, an even power, and an even answer on the outside, we don't need the absolute value bars. All right, let me explain here why we're getting x to the 4th. If we have x to the 8th, that means we have 8 x's that are all being multiplied together. And when we take the square root of that, we want to group them in groups of 2. So I have one group of 2, that's an x squared. And when I square root it, I get an x. Here's another group of 2, x squared. When I square root it, I get an x. Same thing here, and same thing here. So I end up with 4 x's being multiplied together. So our shortcut, instead of having to write this out every time, is just to say we have 8 of them. We want groups of 2. How many groups can we make? We can make 4. All right, let's try another one. This one is an odd root. Remember, odd roots are the easy ones. We don't have to worry about plus minus in front. We don't have to worry about any kind of absolute value around our variables. We are taking the cube root of 27. We're taking the cube root of a to the 6th. And we're taking the cube root of b to the 9th. Okay? Let's do them in pieces. The cube root of 27 is 3. The cube root of a to the 6th. So we have 6 a's being multiplied together. And we want them in groups of 3. So we can make one group there and another group there. We can make 2 full groups of a's. So this is going to come out as an a squared, 2 groups of them. For our b's, we have 9 of them. We're doing groups of 3. We can make 1, 2, 3 groups. So this comes out as b to the 3rd power. So 3a squared b cubed would be our answer. Our next example, we're going back to an even root, so we do have to worry about the even, even, odd rule. The fourth root of 625, if we look at our power chart, okay, fourth roots, 625, its root was a 5. For the variables, we have an x to the 8th, and we're taking its fourth root. Okay, so we have an even situation. The 4 is even and the 8 is even. How many groups of 4 can we take out of 8? We can make 2 full groups. So this is starting out with an even root, an even power, and it comes out with an even power. So we don't need absolute value bars. When we work on the y to the 12th and take its fourth root, how many groups of 4 can we take out of a 12? We can take 3 full groups. But now we started with an even root, with an even power, and we're getting an odd answer for a power. That means we need absolute value bars around that part of it. All right, let's try a couple more. We have the square root of 81x to the 4th. So we have an even root. We have to watch for that absolute value. The square root of 81 is 9. And the square root of x to the 4th. So we're looking at groups of 2. If we have 4 x's being multiplied together, how many groups of 2 can we make? And we can make 2 of them. So we're going to end up with an x squared. So we started out even root, even power, even answer. It's even, even, even. We don't need any absolute value bars. Our next one is a cube root. It's an odd root. We never have to worry about absolute value with odd roots. So we need the cube root of 8. We need the cube root of a to the 12th. And we need the cube root of b to the 15th. The cube root of 8 is 2. For our a's, we have 12 of them. We want groups of 3. We can make 4 full groups. For the b's, we have 15. We're trying to put them in groups of 3. 15 divided by 3 is 5. Okay, no absolute value needed because it was an odd root. Our next one, we're doing the fourth root of 16, x to the 12th, y to the 16th. The fourth root of 16 comes out as a 2. The fourth root of x to the 12th, we have 12 x's. We want them in groups of 4. We get 3 groups. For the y to the 16th, when we take its fourth root, 16 y's, and we're taking them in groups of 4, we can make 4 groups. Now, looking at our even, even, odd situation, we have an even root, we have an even power, and it came out with an odd power. So even, even, odd needs absolute value. For the y's, it was even, even, even. We don't need them around y. All right. Our last example here just says some teachers adjust test scores when a test is difficult. One teacher's formula for adjusting scores is a equals 10 times the square root of r, where a is the adjusted score and r is the raw or original score. If the raw scores on one test ranged from 36 to 90, what was the range of the adjusted scores? So our lowest raw score was 36, our highest was 90. So let's find the adjusted score for each of those. Now we know the square root of 36 is just 6. 6 times 10 would be 60. So they've adjusted it. You got a 36 on the test, they're going to put it in as a 60. Okay? If you got a 90 on the test, when we square root the 90, we can think of that as 9 times 10. We get 3 root 10 times the initial 10. So we have 30 times the square root of 10. But you're not going to put a score like that in the grade book. All right? So we would look at a decimal approximation. And 30 times the square root of 10, let's grab our calculators here. 30 times the square root of 10 comes out to be 94.9 if we round. So we started out with scores from 36 to 90. We've adjusted them to be between 60 and about 95, 94.9. Okay? So you're going to have a couple application questions where you might be dealing with square rooting a number, like this last one. And then we have a whole bunch of questions where you are simplifying roots that contain both numerical pieces and variable pieces. Okay, so homework today is going to be worksheet 6.1a.